Hello everyone, welcome to Maths Wheels. In this session, we are going to learn about chapter 3 of class 10, that is pair of linear equations in two variables. Now, what is a linear equation? It is an algebraic expression whose degree is 1. Let's take an example. 2x plus 5 equals to 0. In this, we have only one variable whose power is 1. That means this is a linear equation. But we want linear equations in two variables, right? So linear equation should contain two variables. Let's take an example. 2x plus 3y plus 4 equals to 0. In this, we have two variables x and y. So this is the linear equation in two variables. Now, if we write this in general form, it would be ax plus by plus c equals to 0, where a, b, c are real numbers and a, b are not both zeros. What we said, a, b, c are real numbers and a not equals to 0 and b not equals to 0. And we often denote this condition a not equals to 0 and b not equals to 0 by a square plus b square not equals to 0. This is the definition of the linear equation in two variables. Now, we want to talk about pair of linear equations in two variables. When we say pair, when we have two equations, right? So that would be a pair. So when we have two linear equations in two variables, then that is called pair of linear equations in two variables. So what's the definition? When we have two linear equations in the same two variables, this is called pair of linear equations in two variables. So what would be the general form of pair of linear equations in two variables? It is a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. So we have two linear equations where a1, b1, c1, a2, b2, c2 are real numbers and a1 not equals to 0 and b1 not equals to 0. That means we denote this as a1 square plus b1 square not equals to 0 and similarly a2 not equals to 0 and b2 not equals to 0, and we denote it as a2 square plus b2 square not equals to 0. So this is the definition of pair of linear equations in two variables x and y. Let's take few examples of pair of linear equations. 2x plus 3y minus 7 equals to 0 and 9x minus 2y plus 8 equals to 0. This is one pair of linear equation. Second example, we can have 5x equals to y and minus 7x plus 2y plus 3 equals to 0. Now, let's understand graphical or geometrical representation of these linear equations. Do you know what do they look like geometrically? Recall that we have studied in class 9th that the geometrical or graphical representation of a linear equation in two variables is a straight line. Can you now suggest what a pair of linear equations in two variables will look like geometrically? There will be two straight lines, right? Two straight lines to represent pair of linear equations. And we have studied in class 9th that if we have two lines given in a plane, only one of the three possibilities can happen. That are, the two lines will intersect at one point. So first one is they intersect. The two lines will not intersect. That means they are parallel. So either they are parallel. And third possibility is they are coincident. We can show these three possibilities in picture like this. First possibility if the two lines intersect, how do they look like? Like this. Second possibility, if they are parallel, the two lines will be like this. And if they are coincident, first line, there can be second line. So these are coincident. So these are the three possibilities for graphical representation. Now let us understand how to find solution of a pair of linear equations in two variables. There are two methods to find the solution of a pair of linear equations in two variables. First method is graphical method and second is algebraic method. Let's first understand graphical method for finding solution of pair of linear equations in two variables. For a graphical method, we have three conditions. First is if a1 by a2 is not equals to b1 by b2. We have second condition, a1 by a2 equals to b1 by b2 is equals to c1 by c2. And the third condition we have is a1 by b2 is equals to b1 by b2 is not equals to c1 by c2. Let's understand first condition, that is a1 by a2 is not equals to b1 by b2. Now what are a1 and a2? Those are coefficients of x. If you see this general form of pair of linear equation, a1 and a2 are coefficients of x. And what are b1 and b2? These are coefficients of y. So basically in first condition, we are comparing coefficients of x and y. Let's understand this from example. We have two equations given, x minus 2y equals to 0 and 3x plus 4y minus 20 equals to 0. Now, if we compare the coefficients of x and coefficients of y according to the first condition, what will we get? a1 by a2 equals to 1 by 3. This is a1 by a2. And what is b1 by b2? It is minus 2 by 4, which is nothing but minus 1 by 2. Now, if you compare the values of a1 by a2 and value of b1 by b2, we can clearly say a1 by a2 is not equals to b1 by b2, right? We have got this condition. So, for these two linear equations, the graph will be two lines intersecting each other at one point. The graph will be intersecting lines like this. The two lines intersecting at one point. And in this case, the pair of equations will have only one solution. That means unique solution. And we know a pair of linear equation which has a solution is called a consistent pair of linear equation. In this case, it will be consistent pair of linear equation. That is all about first condition. Now let's understand second condition. That is a1 by a2, that is a1 by a2 equals to b1 by b2 equals to c1 by c2. Let's understand this from example. We have given pair of linear equation 2x plus 3y minus 9 equals to 0 and 4x plus 6y minus 18 equals to 0. In second condition, we have to compare coefficients of x with coefficients of y along with constants c1 and c2. Let's compare coefficients of x. We get a1 by a2 equals to 2 by 4. We get b1 by b2, that are coefficients of y, that is 3 and 6. And we get c1 by c2 equals to minus 9 by minus 18. So we get a1 by a2 is half. We get b1 by b2 as half and c1 by c2 also 1 by 2. This is b1 by b2 and this is c1 by c2. So we got a1 by a2 equals to b1 by b2 equals to C1 by C2. We got this condition, right? So for a pair of linear equations, the graph will be coincident lines. When we say coincident, the line of one equation will be like this and another graph of the equation, so another line will be like this. So this will be coincident lines. Now for this kind of lines, how many solutions will be there? If you observe, these two lines are intersecting, or we can say overlapping, at many points. So this kind of equations will have infinitely many solutions. Infinitely many solutions. And we know a pair of linear equation which has a solution is called consistent pair of linear equation. So this will also be a consistent pair of linear equation. Now let's understand third condition, that is a1 by a2 equals to b1 by b2 not equals to c1 by c2. Let's understand this from example. A pair of linear equation given here, x plus 2y minus 4 equals to 0 and 2x plus 4y minus 12 equals to 0. Now if you compare coefficients of x, coefficients of y and constants c1 and c2, you get a1 by a2 equals to 1 by 2, b1 by b2 equals to 2 by 4, that is 1 by 2, and c1 by c2 equals to minus 4 by minus 12, that is 1 by 3. So we are getting a1 by a2 is equals to b1 by b2 and it is not equals to c1 by c2. This is the condition we got. So for a pair of linear equation, the graph will be parallel lines. That means the lines which are not intersecting each other. Like this, line for one equation will be like this and another equation will be like this. Now for such pair of linear equation, how many solutions will be there? We know that to get a solution of equation, the lines should intersect each other. But in this case, the lines are parallel lines, that means which are not intersecting each other. So there will be no solution for this type of linear equation. So there will be no solution. And we know a pair of linear equation which has no solution is called inconsistent pair of linear equation. So this will be inconsistent pair of linear equation. Now let's quickly revise what we learned. The first condition, a1 by a2 is not equals to b1 by b2. The graph of such linear equations will be intersecting lines and it will have only one solution, that is unique solution, and those are called consistent pair of linear equations. Second condition, we have a1 by a2 equals to b1 by b2 is equals to c1 by c2. For such pair of linear equation, graph will be coincident lines and it will have infinitely many solutions and it will be consistent pair of linear equations. Third is a1 by a2 equals to b1 by b2 not equals to c1 by c2. For such pair of linear equations, the graph will be parallel lines and it will have no solution and it is called inconsistent pair of linear equations. Next method is algebraic method. It has three types: substitution method, elimination method, and cross multiplication method. Let's understand substitution method first. Suppose we have a pair of linear equation given, that is x plus y equals to 16 and x minus y equals to 4. How to solve this using substitution method? What do we mean by solving? Solving means finding the values of x and y. Here, the name of the method, that is substitution itself, indicates we have to substitute the value of variable x or y. Now to find the solution, let's take first equation x plus y equals to 16 as the first equation and x minus y equals to 4 as second equation. Now to find the solution, let's take any of this equation and find the value of variable. Let's take first equation here, x plus y equals to 16, and calculate the value of x. It would be 16 minus y. Now let's put this value of x in this second equation. What is our second equation? x minus y equals to 4. What is the value of x we got? 16 minus y. So it would be 16 minus y minus of y equals to 4. So we get 16 minus 2y equals to 4. So 2y equals to 16 minus 4, that is 12. So y equals to 6. Now we have found the value of y as 6. Let's find x now. What is x? X equals to 16 minus y. So this will be 16 minus 6. So we get x equals to 10. Isn't it simple? So in this method, we are basically finding the value of one variable from any one equation, and we are putting that value in the second equation to find the value of second variable. Let's understand elimination method now. Suppose we have a pair of linear equation given 3x plus 4y equals to 10 and 2x minus 2y equals to 2. In elimination method, we have to eliminate any one variable from the two equations given. Let's understand how to eliminate the variable. Suppose 3x plus 4y equals to 10, this is our first equation, and 2x minus 2y equals to 2, this is our second equation. Now, to eliminate the variable, first thing we need to do is to make these coefficients equal. How to make them equal? Whatever is the coefficient of x in second equation, that is 2. Multiply the first equation with the coefficient of x in second equation. So, if we multiply the first equation by the coefficient of x in second equation, that is 2, and if we multiply the second equation by the coefficient of x in first, that is 3, we will get the coefficient of x in both the equations as equal. So let's multiply first equation by 2. What we'll get? 6x plus 8y equals to 10 into 2, that is 20. And let's take this equation as third equation. And let's multiply second equation by 3. So what will we get? 3 into 2x minus 2y equals to 2 into 3. So this will be 6x minus 6y equals to 6. Let's name this equation as fourth equation. And now if we subtract 4 from 3, what will we get? 6x plus 8y equals to 20 minus, we have to subtract fourth from third. So this will be 6x minus 6y equals to 6. What you get? 6x minus 6x, it will be 0. So no need to write. Now let's subtract 8y minus of minus 6y. This will be plus 6y. So this will be 8y plus 6y, that is 14 of y equals to 20 minus 6, that is 14. So y equals to 1 we get. Now let's substitute this value of y in any of the given equations. You will get x, right? So let's take the first equation and substitute the value of y as 1. We get 3x plus 4 into 1 equals to 10. That is 3x equals to 10 minus 4. So 3x equals to 6. X equals to 6 by 3. That is 2. So x equals to 2 and y equals to 1 are the solutions of the given linear equations. So in this method, we are basically making the coefficients of any variable equal and we are eliminating it. So in this case, we made coefficient of x equal in both equations and we subtracted it to eliminate it. So that's all about elimination method. Let's move on to cross multiplication method. Let's understand this method from example. We have a pair of linear equations given 2x plus y minus 5 equals to 0 and 3x plus 2y minus 8 equals to 0. Let's take this as first equation and this as second equation. Now for a cross multiplication method, let's write whatever variables we have in the equations like this. X divided by equals to y divided by equals to 1 divided. Okay. Now let's calculate the denominators. What is the denominator of x? If we cover the x variable terms from the both equations by your hand, so if you cover this 2x and 3x, what is left out? Y minus 5 and 2y minus 8, right? So you have to cross multiply the coefficients here. So what is the coefficient of y? It is 1. So multiply 1 with minus 8, you get minus of 8. Let's put minus sign here. And what is the cross multiplication of 5 and coefficient of y is 2 here. So 5 multiplied by 2, minus of 5 is, so minus 10. Similarly, let's find the denominator of y. To find it, let's cover the y variable terms. So if you cover the y variable terms with your hand, what is left? 2x minus 5 and 3x minus 8. So these terms you have to cross multiply, 2x with 8 and 3x with 5. So we have to cross multiply only coefficients. So what you will get, 2 multiplied by 8, you get minus, it is minus 8, so you get minus 16. Put the minus sign, and minus 5 multiplied by 3, you get minus 50. Similarly, now if you cover the constant terms with your hand, and if you do the cross multiplications of the left out terms, what is left out here? 2x plus y and 3x plus 2y, and you do the cross multiplication between these terms, only the coefficients, right? So what you will get, 2x multiplied by 2y, that means only coefficients, 2 into 2, that is 4, put the minus sign, and 3 multiplied by 1, that is 3. Now if you observe, there is equal to sign in between these terms. So you can equate this with this last term, or you can equate this with this, and you calculate the value of x or y. Let's equate first term with the last term. What you get? X minus of minus 8 plus 10 equals to 1 by 4 minus 3 is 1. That is x by 2 equals to 1. So x equals to 2. So this is the value of x we got. You can substitute this value of x in any of the equations given and you get the value of y. So let's substitute this value in the first equation. What you get? Plus 2 minus 5 equals to 0. So y equals to 5 minus 4. Y equals to 1. So x equals to 2 and y equals to 1 are the solutions of the given linear equation.